We can use this formula to calculate the length of the arc PQ. So arc then equals 110 degrees over 360 degrees multiplied by 2 pi, and the radius of the sector is 5, 2 pi times 5, which gives us 9.599 centimeters, or 9.6 centimeters. For part 2, what we're going to have to do first of all is work out this angle here, and that angle is 360 degrees minus 110, so that gives us 250 degrees. That's the angle at the centre of the major sector. We want to work out the area, so area is 250 degrees over 360 degrees times pi r squared. Now r is 5, so that's pi times 5 squared. And it gives us 54.54 centimeters squared. So area equals angle over 360 degrees times pi r squared. I used that formula in the last question without writing the formula down. In this case, we are told that the area is 55.8. We don't know what the angle is, but we do know that the radius is 8. So what I'm going to do first of all is multiply by 360 degrees to get rid of the fraction. And that gives 20088 equals angle times 64 pi, and what I want to do now is to divide by 64 pi, and the angle then is 99.9 degrees, and we'll round that up to 100 degrees. Calculate the area of the sector. So it's angle over 360 degrees times pi r squared, 60 over 360. And that gives us the value 52.36 centimeters squared. Calculate the area of the triangle. Now it's not a right angled triangle, very few of these triangles are, so the formula is a half AB sine C. So it's 1/2 of 10 times 10 times the sine of 60 degrees, which gives us 43.3 centimeters squared. And the last thing we can do is to work out the area of the sector. Not the area of the sector, this part here of the circle is called the segment. So it's 52.36 minus 43.3, and that gives us 9.0587, and we can maybe round that to 9.1 centimeters squared. So we're going to do exactly the same thing for this. The first thing to do is to work out the area of the sector, and that was angle over 360 degrees multiplied by pi multiplied by 12 squared, which gives us 100.53. want to work out the area of the triangle. That's a half of 12 times 12 times the sine of 80 degrees. That comes to 70.906 centimetres squared. And the shaded area then is 100.53 minus 70.906, which gives us 29.62 centimetres squared. The volume of this prism is A times H, where A is the area of this shaded end here. So we'll work out that first of all. It's a right angled triangle, 1/2 the base times the height. So it's 1/2 of the base is 7 and the height is 4, or vice versa. We don't need to worry too much about that. 4 times 7. So the volume then is 14 times 10, which is 140 cm cubed. Part B, what we have is a cylinder, pi r squared h. The radius of the base is 4 and the height is 12, and that gives us 603.186. The volume of a cone is 1/3 pi r squared h, so it's 1/3 pi. Now the radius of the base is half of 15, so it's 7.5 squared times 9. 530.143 cm cubed. Part D. Now the volume of a sphere is 4/3 pi r cubed. The radius of this is 10. So we get 4188.79. But we have to remember to divide by 2 because we've got a hemisphere here. So the final answer is 2094.4 centimetres cubed. So the volume of the cylinder is pi r squared h. Now we're told that the base diameter is 90 cm, so the radius of the base then is 45 cm. And the height is 1.5 metres tall, but why don't we convert that into centimetres? So times 150. And the answer we get is 954,258.768. We want to convert into litres, so we'll divide that answer by 1000. And that gives us 954.26 litres. What we have to do now is to divide by 4.5, and that will give us the answer in gallons, and that's 212.1 gallons. Factorize Part A, nice and simple, common factor. Take out x, we've got x plus 5. Part B, And what we have here is a difference of two squares. So what I could do is write the second term as 4b all squared. And then a plus 4b. Part C, the first thing I can do is take out a common factor. Should always look for a common factor first. And then what we have is a difference of squares, so it's going to be p minus 3, p plus 3. X to the power of 4 minus 81. Well, this is a difference of squares too. That's x squared all squared minus 9 squared. So I can have x squared minus 9. And then x squared plus 9. But we just saw up here that p squared minus 9 can be written as p minus 3, p plus 3. So I can, in fact, expand the first bracket into x minus 3, x plus 3, and then multiplied by x squared plus 9. Part T, the first of the trinomials. Factors of 12. That will give us a 7. It's got to be 4 and 3. Now remember, that sign, that positive sign, tells us the signs in the brackets are the same, and this positive sign tells us that they're both going to be positive. And finally, part F. So what we want now is the factors of 20. That will give us a 9. It's going to be 4 and 5. Signs are the same, but in this case they are both negative. The problems are getting just a little bit more complicated now. Well, this is a trinomial as well. So p times p will give us p squared. We want the factors of 21, that will give us a 4. Well, that's going to be 7q and 3q. Now we want a minus 4pq, so I'm going to have a minus here with the 7 and a plus with the 3. Remember, a negative sign in this position means the signs in the brackets are different. 3x squared plus 5x minus 2 . Factors of 3 are 3 and 1. Factors of 2 are 2 and 1. Now we need to be able to get a 5. But remember, the signs are different. That's what that negative means. 3 times 2 is 6. 1 times 1 is 1. From a 6 and a 1 I can get a 5. So I'll put the 3 and the 1 in this position. 3x and 1x. And then the 1 and the 2 in this position here. Now I want to get a plus 5, so that's going to be a plus 6 and a minus 1. What I'm going to do with this one, first of all, is take out 5 as a common factor. Remember, these problems have to be factorized fully. So if you leave in a common factor, which can be taken out, you lose a mark. We're left with a nice simple trinomial. It's got to be x and x, 2 and 1. The signs are different because of the negative in this position here. We want a plus 1, x, that's to say I could have put a 1 here, so it's going to be plus 2 and minus 1. So factors of 9, 9 and 1, 3 and 3. Factors of 16, 16 and 1, 8 and 2, and 4 and 4. I want to be able to get a 24 in the middle, and I know what I'm going to do. I'm going to have 3 and the 3 and the 4 and the 4. 3 times 4 gives me 12, and 3 times 4 gives me 12. And 12 and 12 gives me 24. So it's going to be 3x and 3x, 4 and 4. Signs are the same because of the positive in that position, and they're both going to be positive. So I'm going to put 3x squared here and x squared here. I want to get a plus 5. Now the factors of 2 are 2 and 1, so I'm going to put the 2 here. That will give me a 6x squared, and I'll put the 1 here. Now the signs in the brackets must be different because of this negative, so I'm going to put the plus here. That will give me a plus 6x squared, and the minus can go here. Similarly, in this question, I'm going to have an x squared, 2x squared, and an x squared here. Now the factors of 15 are 5 and 3. I'm going to put the 3 here. That will give me a 6x squared, and I'll put the 5 here. From a 6 and a 5, I can get a minus 1, and I'll put the negative in this position and the plus in this position here.